So yesterday, kind of in our 3.1 and 3.2 intro, we talked about kind of scale factor and how the properties were similar, right? Some of the things that we've already gone over. So now we're going to get into how we can use scale factors to draw similar figures or to find missing side lengths in similar figures. So now comes the real problem solving kind of after getting our little intro yesterday. All right. So down here it says the scale factor from one figure to a similar figure gives you information about how the side lengths, perimeters, and area of the figures are related. So it says for questions A and B, use the two figures below. So we have a rectangle and a triangle here, right? This rectangle has a width of what? What's this width? 4, right? There's 4 blocks. And what about the length? 8, right? Now remember, triangles, we go on base and height, right? So the base of this triangle is what? The base. 7. And the height goes from this tip down here, right? Which is what? 4. The triangle and the rectangle are the same height. So I got some grid paper, or if you just want to calculate it, what I want you to do is spend some time with your teammates for part A and B. Okay, for part A, there's different scale factors they want you to do for the rectangles. Okay, so they want to go from rectangle A to a new rectangle that is 2.5, the scale factor. Okay, then it says the perimeter of the new rectangle is 3 times the perimeter of rectangle A. That's 3. Number 2 is that the area of the new rectangle is 1/4 the area of rectangle A. And what I want you to try to do is figure out the dimensions of those rectangles. What are we talking about here? What size? Okay, so one is dealing with a side length. The other is giving you an area. The other one's a perimeter. Remember, we talked about those yesterday and how they're related. Okay, so if you need to even refer to those notes yesterday, go ahead and do so. And then in part B, we're going to tackle the triangle, which is figure B, right? So they'll give you a triangle that's 16 times the area of triangle B, and then a scale factor that's a half of the new triangle, half the size of the original. Okay, and again, we'll see if we can figure those out. So we'll give you guys some time to work on this. Say at least, I'll check in at least 10 minutes and see how you're doing. Okay, on the I believe it's the back. If you flip it over, you got a little grid paper there. You can do some sketching on that if need be. Okay, to help you. And if you want to do your calculating on the front parts, you can do that. All right, any questions on what you're going to do? All right, we'll let you work. If we take a look at just the rectangles for right now, okay? So the scale factor is 2.5, right? That means each side of the rectangle we want to multiply by 2.5. So you should have taken 4 times 2.5 and 8 times 2.5, right? So what's 4 times 2.5? 10. And then 8 times 2.5 is 20. So your new rectangle should have dimensions of a 10 by 20. Now remember, the area of a rectangle is 1/4 the area of rectangle A. So remember, it's some number times itself to get the scale factor times itself to get to the area, right? So what times what gives you 1/4? Half, right? So the scale factor for this is a half, because a half times a half gives you 1/4, which is the area. So now if you take 4 and multiply it by a half, and 8 and multiply it by a half, you get a 2 by 4 rectangle. How many people got that? Good. Now the perimeter, it's the same, right? So if the perimeter of the new rectangle is 3 times the perimeter, 3 times, so that means the scale factor is 3. Right? So you're going to multiply 4 times 3 and 8 times 3, which is 12 by 24. So you should have a 12 by 24 rectangle for the third one. How many people got 3? 12 by 24. Good. A lot more hands up on that one. Okay. So now let's go to the triangle. Okay. So the area of the new triangle is 16 times the area. So what number times itself gives you 16? What number times itself gives you 16? Blake? 4. So that means your scale factor for this is 4. Because 4 times 4 gives you 16, which is the area, right? So if you have the base, right? The base of this was 7, so you're going to multiply that times 4. And the height of it was 4, so you're going to multiply that times 4. So your triangle should look, it should be 16 tall, and the base should be 28. How many people got that? Base is 28, height was 16. Good. Couple hands. And then the scale factor of triangle B, it's a half, right? So that's what's telling us. The new triangle is a half. So which means the old triangle, right? The base was 7, so we have to multiply that by a half. Because remember, we're making it smaller, right? When it's less than 1, we're making it smaller. When it's bigger than 1, we're making it bigger. We're scaling up, right? And 4 times a half. Well, 4 times a half is 2. What's 7 times 1/2? Huh? 3.5. So again, your new triangle should have it's a height of 2, and your base is 3.5. So how many people found that? All right, good. All right, let's flip it on over. So if we flip it on over, we got 2 rectangles here. Okay. So it says these 2 rectangles are similar. We want to figure out what this side length is, AD. Okay. So remember, we're going smaller. Okay. We're going smaller. So side EF gives us 6.75. What side is similar to EF? You got to be careful now. Look really hard. What side is similar to EF? Blake? DC. Because this thing is actually turned upwards, right? It really should be going this way. Right? So yes, these are the 2 sides that are similar. So if we want to figure out the scale factor, right, we're going to take 3 and divide it into 6.75, which is what? Anyone got a calculator handy? What's 3 divided by 6.75? Isabel. Right, so it's 0.4 repeating. So that's our scale factor, right? 0.44444. So now, if I want to find AD, what side is AD similar to? Aiden. EH, right, which we know is 9 centimeters, right? So if we take 9 and multiply it by 0.4 repeating, we should get our answer, right, which is what? If you do 9 times and just put like 0 point and put a bunch of 4s, hit enter. I think it actually comes out to a whole number. Nobody? 4, right? Isn't that what it said? So the new side would be 4 centimeters. And that's how we can use scale factors to find missing sides. Remember, we're going from big to small. So that this number, our scale factor, has to be less than 1. We're going big to small. All right, let's try the same thing with a triangle now. These 2 are similar, right? AB and DE are the same sides, right? So are we going small to big or big to small? Yeah, we're going small to big, right? So if we want to figure out our scale factor, we're going to take, let me just erase that. 7.5 and divide by 6, right? Which is what? What's 7.5 divided by 6? 1.25. Okay, that's our scale factor. So what we're going to try to find here, and I'm going to have you guys do this, is we need to figure out what the length of DF is, what EF is, okay? And then what do we know about the angles of similar figures? What do we know about corresponding angles? Blake?
They always stay the same.
They're the same, right? So notice A and D are both 56 degrees. So what would angle F be? What would angle F be, Gavin? 94 degrees, okay? What I want you guys to figure out is what angle B is and what angle E is also. Okay? So you got to figure out what lengths D and F are with a scale factor of 1.25, E and F, and angle B and angle E. All right? So we'll give you guys about 5 minutes to figure that one out. We'll let you guys work. So after we fixed angle F to degrees and not percents, what was the length of DF? Side DF, right here. Aiden. Yeah, because you had to take 3, which was on the original figure, right? And multiply it by 1.25 to get 3.75. Good. What about EF? Side EF, right here. Isabel.
6.25.
Good, because we take 5 times 1.25. Excellent. Now, what did you figure out? First of all, angle B. How'd you figure out angle B? Ava.
Well, I know that all angles add together to equal 180 for triangles. So I added 56 and that equal and got 150. So then I minus 180 and 150.
Okay.
Got 60.
Yeah, all the angles of a triangle have to add up to 180 degrees, right? So she basically added these two together, which came up to 150, and subtracted it from 180 to get 30 degrees. Well, once you figure out angle B, then angle E it's the corresponding angle, right? Which means it's the same. So that's 30 degrees. Okay? And thus we got all of our angles and all of our sides. Okay? All right, so we go to the summary. So again, you can calculate the scale factor to find the missing sides. Whether we go from big to small or small to big, right? And then in similar figures, the corresponding sides or angles are congruent. So if you know the measure of one angle in the one figure, the corresponding angle of the similar figure is the same angle, right? This is what we've been kind of working since investigation 2. And again, this was a big one. This helped you solve that one. The interior angles of a triangle have to add up to 180 degrees. Okay? So there is a homework assignment with this. Page 60, 1 to 6. Okay? Page 60, 1 to 6. We're going to